Okay, so we're going to do applications of normal distributions. Let me find my mouse and keep going over. Did that change it? I don't really know where, okay, there's where it thinks my mouse is. Okay, so standard normal distribution curve can also be used to solve a wide variety of practical problems. The only requirement is that the variable must be normally or approximately normal. So that it'll usually say something in there. The variable is normally distributed or approximately normal. All problems presented in this chapter, you can assume that it's normal or approximately normal. So even if it doesn't say that in the problem. In the future, usually you'll look for something that says that. Okay, so to solve problems using the standard normal distribution, transform the original variable of whatever we're given into a z-score. So we're going to use our z-score formula. And then we're going to use that same chart then after we find the z-score. Okay, so still table E is that the name of it. This is table A. So what the heck does it ask you for in table E? Now I don't know that either. That's appendix C is tables in H. I'm almost closer to it. H. C, D. Did I skip E? Standard normal distribution. Oh, I have a different copy for you. So it's the same thing. Okay, so anything that says table E, use this thing. I must have got it out of a different book or something so that it was a bigger copy. I didn't know I did that though. Okay, so we're gonna do example 6.6 and the first thing in section 6.2. Where'd my clicker go? Okay. A survey found that the women spend on average $146.21 on beauty products during the summer months. Assume the standard deviation is 29.44. Find the percentage of women who spend less than $160. So less than is good because when we think about that normal curve, a normal curve looks like this, less than, so 160. So I can kind of think about it as, this is 146 in here, and you don't have to draw it with all of the actual values in there. The one thing that kind of, 160, at least that's above here. So less than means I'm finding this area. Okay, remember that that's the way that it already is in your chart. Hey, it's above half. I know I'm going to be using that right-hand side of it. So those are just kind of things you can think about. I'm not necessarily always writing down. Although that's about as much as I would write down. I would write that much down for about each problem. Standard deviation is 29.44. So we're going to use our z-score formula. And our z-score formula is z equals mu, or x minus mu, sorry about that. X minus mu over sigma. Remember, mu is this guy up here. That's our average. Sigma is our standard deviation. X is the one we're actually looking for. So we care about that x value. So stuff we're doing z equals 160 minus 146.21 all over sigma of 29.44. Okay, so definitely have a calculator handy. I don't know, does it tell me? So it kind of just, the next slides kind of go through, okay, we drew it. Okay, look, we found it. It was 0.47, so our z-score is 0.47. Hey, look, that's positive, so we were right there. That's what we expected. Anything on that positives on that right-hand side. Make sure, so if you're typing things in, the only weird thing is make sure you get parentheses around the top if you're doing it all in one step. Generally what I do, I don't even try to think about parentheses. I do my subtraction. I do like 160 minus 146.21. Press enter. Whatever I would happen to get, then I'm going to divide that by 29.44. Okay, just don't lose those order of operations in there. Because if you type it all in one line, you totally get the wrong answer. Remember, standard deviations or z-scores, we really don't expect much of anything above or below +3 and -3. Okay, every once in a while it happens. So now we're looking at our chart to find 0, 4, 7. So we find 0.4, go across to 7, I get 0.6808. Okay, so hopefully you can find that same number. Okay, so what that means is 68% of women that spend $160, 68% of them spend less than $160. Okay, now for 6-7A. Each month an American household generates an average of 28 pounds of newspaper for garbage or recycling. That's a lot. Assume the standard deviation each month. That's a lot for a month, I think. Assume the standard deviation is 2 pounds. If a household is selected at random, find the probability it's generating between 27 and 31 pounds per month. Assume the variable is approximately normally distributed. Okay, again, that last sentence is probably not going to be on all of your stuff. Okay, so what you're going to do, you're going to go in and say, okay, what is my normal graph, my normal curve going to look like? So I have 28 is right in that middle. That's my mean. 28, 27 is slightly below that. 31 is slightly above that. And my standard deviation is 2. Okay, so if I really wanted to count, I could do a little bit more. So that should be like 2, and that should be another 2. You don't have to draw all that there on there. Okay, standard deviations are kind of hard to put on there when you're just sketching a quick graph. Okay, so we're finding our z-score for both of these numbers. So that's where it's going to be a little bit different from that other one. So convert both of those things to z-scores. So our z-score for 27 is not x, z equals 27 minus 28 all over 2. -1 over 2. Everything on that chart is in decimals, so it's -0.50, just to make it kind of nicer. Everything has that 1 digit up front, the 2 in the back. Okay, and then we have to do it for 31. Z equals 31 minus 28 over 2. 3 halves. 1.50. So you're going to go in on your chart, make sure you can find everything using your chart. Negative 0.50. Negatives on the left-hand page. Negative 0.5, so it's close to the bottom. 0.50. So make sure it's in that first column. What'd you get? Okay. Okay, so that was the bottom one. So that's that guy right there. And then the other one, what's the 1.5? It's positive, so it's on the right-hand side. 0.9332. Okay, between, subtract the least less from the most one. I've seen those before. Okay. So there you go. Then when you subtract them, I bet it will have it already subtracted for us. 0.6247. So then we can say the probability is about 62% that, I don't even remember what the original question asked, that amount of recycled paper, 68% would have between those values is something like it would look. Okay. Americans consume on average 1.64 cups of coffee per day. Assume the variable is approximately normally distributed with a standard deviation of 0.24 cups. I guess just cup, anything less than 1. I always think that's weird. I still make it plural. If 500 individuals are selected, approximately how many will drink less than 1 cup of coffee per day? Okay, so less than, again, that's the one we want. Draw your quick graph. So 500, that's going to add in one more step. So that kind of is one that you might, it's a little bit trickier. So we'll drink less than 1 cup of coffee per day. So 1 cup, we have to find our